Okay, welcome to day 7 of Advent of Code 2023. We recorded this in 2024 now because I didn't manage to get all these videos done in 2023, but here we go. So, day 7. This one was a fun one, camel cards. It's pretty easy, but really fiddly. I'll show you what I mean. There's a few little things in here that I when I solved it, I put in that are Python specific. Easy enough, I guess, to do in other things, but I used a couple of little things that just kind of Python specific to solve this one. So anyway, let's look at the problem. So if we skip over some of the law here, and let's go down to the cards. So we're offered to play cards, or offered to be taught a game of camel cards. And it's sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands. Your goal is to order them based on the strength of each hand, and a hand consists of 5 cards labelled one of A, K, Q, J, T, 987, 6543, or 2. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. So, Ace, King, Queen, Jack, T for 10, 9 through 2. So you've got the order of the cards there, just like normal physical cards would be. So in every hand is exactly one type, from strongest to weakest. They are 5 of a kind, where all 5 cards have exactly the same label. 4 of a kind, where 4 have the same label but one card is different. A full house, where 3 cards have the same label and the remaining 2 cards share a different label. So there are two labels, ultimately 5 cards. 3 of a kind, where 3 cards have the same label and the remaining 2 cards are each different from any other card in the hand. A 2 pair, where 2 cards share one label, 2 cards share a second label, and the remaining card is a third label. 1 pair, where 2 cards share one label and all the other cards are different from each other. And a high card, where all the cards are labelled distinctly. Hands are primarily ordered based on each type. For example, a full house is stronger than any 3 of a kind. If 2 hands have the same type, then we fall back to a second ordering rule. So we start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card is the same, then move on to the second card and keep going and going and going until you get to the end. So with this and this, they are both 4 of a kind, but 3-3-3-3-2 is stronger because the first card is stronger. Similarly, this and this are both a full house, but this one is stronger because its third card is stronger, and both hands have the same first and second card. To play camel cards, you are given a list of hands and a corresponding bid, your puzzle input. So in this example, we've got 5 hands. Each card is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets a rank of 1. The second weakest gets a rank of 2, so on and so forth. So the first step is to put the hands in order of strength. So using these rules above, we put them in a particular order, and then you determine the total winnings for the set of hands by adding up the results and multiplying them by each hand's bid multiplied by its rank. So 765 for the least times 1, plus 220 times 2, so on and so forth. Total winnings for this example are 6440. Find the rank of every hand. What is the total winnings? Okay, so this one was quite easy, I think. It was just a bit fiddly to do. So let's kind of talk through what we're going to do. Firstly, we've got the ordering here. So this ordering is actually going to come in useful. The way that I did it, and the way I'm going to show you, is put these into a list or a tuple or something where we can get the put them in an order. We say it's an ordered list or an ordered tuple, and that way we can use the index plus 1 to determine the priority of these individual cards. So ace is the highest, K is second highest, so on and so forth. So we can then use the index to determine which one is better. So if we're comparing Q against J, Q is going to win. Someone like that. Cool. And then so we have the different types here as well. So then the other thing we need to do is sort of determine the order of these. So if we get, for example, a 4 of a kind, that will beat everything else, but it won't beat a 5 of a kind. So we need to be able to say what type it's going to be, and then also order it based on the type. So let's dive in. Okay, so I've got the test input up the top here. Got the test solve. So if we just very quickly add in here, instead of assert false, let's go with assert solve with the test input. Test input is equal to, and now we have the number here that we're going to be looking for. So it's 6440. 6440. Cool. So that will give us the test to make sure that this works. So firstly, let's determine these card ranks. So rather than type them all out, I'll just copy it from here. And let's just do card ranks is equal to, if we just pop them in here, get rid of all of the commas and spaces, just clean it up a little bit, like so, and then we can simply wrap that in a list. So that will give us separated out. There's all the different ones that we need. Then we have the type ranks. Now, so we've got 2 Fs. So for this, I'd probably propose being 5 and then a 4, an F for full house, a 3, a 2, a 1, and then this high card, maybe H, just to represent them. So if we then do type ranks is equal to, let's just do a list again, and so this one we want it to be we want to go lowest to highest because we want to give the biggest score to the best one. So for this, we'd do H, 1, 2, 3, full house, 4 of a kind, 5 of a kind. Cool. So, in fact, this, we should probably reverse. So let's just reversed like that. Because we want that ordering to again give the highest score to the best one. Cool. Okay, so then we want to keep track of all the different hand scores, because we want to then be able to give the final score, which will be the hand score ordered correctly, with the rank of it, which will be the index of what we're going to have, and then multiplied by the bid, which is here. So for this particular one, let's just simply make not hand scare, but hand score is equal to a empty list. Cool. So we want to go over all of the hands in the input. So if we do for hand in string dot split lines, so we want to split that on a space so that we can get the cards and then the bid. So if we say the H, or the cards, and the bid is equal to the hand dot split, and that will separate on white space, which will be the but we may also, just thinking about this one, we may also get an extra bit on the end, so we might want to strip that down. We'll cover that if we get to it, if we need it. So firstly, what I'm going to do, so this was the Python specific piece that I mentioned. So I'm going to create a counter, and we're going to just set that to a counter we want it from collections. It's not there. No. So if we just import that at the top here, let's get rid of that. Where are we? There we are. From collections, import counter. Cool. So then we have the counter here, and to start with, we are just going to pop in the cards. So that's going to give us, because the counter takes an iterator, or an iterable, sorry, and we can iterate over a string. This is going to separate everything out from the string and give us a count of all of the individual cards that are in that particular one. Now, we don't necessarily, in this part, need to care about the order of the cards, but we do need to care about how many there are of each particular thing. So let's firstly let's make a type or a type variable, which will be a string that just holds the type that we're going to save. And then let's figure this out. So easiest one to start with is if we have a count of 5, then we know that we're getting 5 of a kind. So if max counter dot values is equal to 5, then t is equal to, and this is the one we give it up the top here, 5. So then we want elif max of counter value. So this is very repetitive. This part is equal to 4. Then t is going to be equal to 4. Now, for these next ones, this is where we actually need to start considering how many cards, how many groups of cards there are. So if we say elif, again we want to get the max counter dot values. So this one, for the next two, we're looking at, there is 3. So for this particular one, we're looking at a full house and 3 of a kind. So we'll start with the full house. So where there's 3 cards have the same label. So this is the max amount of a particular card is 3, and the remaining 2 cards share the same label. So a counter will have a length of the amount of cards that there are. So we can then say and len of counter is equal to 2. So then here a type is going to be equal to a full house. Then what we can do is, if we just select this, yank, paste, if we then go to the end, go back here, we want to replace the 2 with a 3. And instead of that being a full house, that is then going to be a 3 of a kind. Excellent. So then the next one down here, we're going to do 2. So we have a 2 pair where there's 2 cards share one label, because we've just done the full house and the 3 of a kind. So now we have a 2 pair where 2 cards share one label, 2 cards share a second label, and the remaining card is a third label. So it's going to be maximum count of a card is 2, but the length is going to be 3. So if we change this to a 2, there are going to be 3 cards. Then this becomes a 2 of a kind. Finally, we then have, so there's 2 more to go, because we have the high card one as well, where there's all individuals. So the last of the ones that have multiple conditions, we then have where the maximum is 2, but the length is 4. So this instead will become a 1 pair. Cool. And then we have finally a length. So with this one, we don't care about the maximum counter. We could say that this is equal to 1 and the length of the counter is 5. But essentially, if it is a length of 5, then it's going to be 1. We could also just have the maximum value is 1. This would also give us the same thing. We don't need both. In this particular instance, we don't need both. But let's leave it in there just for the sake of it. Okay, so this is going to be a high card. Cool. So we need a way to keep track of the card scores for this particular hand as well, because we need to be able to order by that if necessary later on. So if we just go down here and do card scores, so this will be equal to the card ranks, which we've got up here, and we want to get the index of X for X in cards. So that's going to give us the score, with the lowest being 0, highest being however many cards there are. Yeah. So that way we can card for card compare the index, get the highest ranking one later on if we need to fall back to that particular thing. Finally, if we then add this to the hand scores variable, so we want to, if we give it a tuple of the cards, the type, the card scores, and an int representation of the bid. Cool. Okay. So what we want to do as well within this solve function, if we, before the iteration, we don't want to create it every single time, but if we create a function that we're going to use to sort things by, so this is going to, let's say it takes an item, which is going to be essentially a tuple of string, list of integers, and then an int, and it's going to return an int. No, it will return a tuple, but still. So let's just do this. So what we want to do here is return a tuple of type ranks dot index of item, and we're going to use this one, so it's the first entry there, and secondly we then want the card scores. So this will give us a sorted list of all of the card scores that we've got. So we want item 2. Cool. So then if we go all the way down here, so we're going to append all of those, and then finally we get to setting the total. So we're going to do total is equal to the sum of all of these. So we're going to do I multiplied by so the I is going to be the index of the sorted hand scores. We're going to sort it using this sort function here. So we then want to sort it by the bid of the hand scores, which is the 0, 1, 2, 3. So let's just say x3 for I x in enumerate sorted hand scores. Key is equal to sort function. And yeah, enumerate starting at 1, because if we just did enumerate, it's going to start at 0, whereas if we enumerate over this starting at 1, we then get 1 times the bid, and so on. So let's just see if this has done what we need. So we're on day 7. So if we do PyTest part 1 and run part 1, excellent. So we get a passing test and we get the actual output here. So let's double check that. 251 806 792. Perfect. There we go. Yeah, so this one was nice and simple, I think. Simply creating the type, or determining the type, and then getting the scores of all of the individual cards, sorting it by in a particular way, which will be getting the item index for the type, and also the ordering it by all of the individual card scores for that particular hand. If it gets a match. So yeah, that was that one. Nice and easy. So part 2, as you could see from the beginning bit here, we now have jokers. So instead of a jack, or the equivalent of a jack from a set of cards, we now have J as a joker. So they are wild cards that can act like whatever card would make the hand the strongest type possible. So to balance this, J cards are now the weakest individual cards, weaker than even 2. The other cards stay in the same order. J cards can pretend to be whatever card is best for the purpose of determining the hand type. For example, is now considered a 4 of a kind. However, for the purposes of breaking ties, the 2 hands of the same type, J is now considered a J, which, as per this, J is now the weakest card. And it's not the card that it's pretending to be. J, KKK, 2 is weaker than QQ2, because J is weaker than Q. Which it was anyway. Yeah, I think it was anyway. But yeah, so because this has been upgraded to a king, the Jack has been upgraded, or the Joker has been upgraded to a king, you would assume that it would be a king, but it's not. It's going to stay a Joker, and because Joker is the lowest scoring, the tie is broken by this one winning because J is weaker than Q. So these now change a little bit. So 3-2-T-3K is still the only one pair that doesn't contain any jokers, so its strength doesn't increase. It's now the only 2 pair. These 3 are all now 4 of a kind. This particular one gets a rank of 3, this one gets a rank of 4, this one gets a rank of 5. With the new Joker rule, the total winnings in this example are now 5905. Using the new Joker rule, find the rank of every hand in your set. What are the new total winnings? So, this essentially uses a lot of the same code. So, I'm going to cheat a little bit and grab everything. Yeah, do you know what? I'm just gonna select everything. Let's grab that. Let's go over to part 2 and let's paste it in there. So, changes to this one. Firstly, the card ranks now have changed. So instead of the J being here, the J is now over here. The type ranks are still the same. This all still works. The sort is still the same. So now we, instead of having this particular setup for determining the type, we now have some other options. So, firstly, if the maximum counter values is 5, then what we're going to do is keep it as a 5. If it is a 4, we're then going to check if J is in the counter. So if J is in the counter, then T is equal to a 5 of a kind, else T is equal to 4. So what we've done here is just say we did have a 4 of a kind. If we're looking at these rules up here, if we did have a 4 of a kind and there is a Joker, the Joker then becomes the card that makes it into a 5 of a kind. So we're going to upgrade it to whatever card it is. We don't care what card it is. We're just going to upgrade it to that. And if there is no Joker, then we're going to keep it as a 4. So that was nice and easy. Then we get to 3 of a kind, where there is 4 of a kind. Sorry, not 4 of a kind. Full House. This was a 4 of a kind. So this one, in fact, I'm going to make some notes on here. So we have, this one is 5 of a kind. then this one would have been 4 of a kind. So this one would have been a full house. So what we're going to do here is just say, okay, so if we have 3 and there are 2 values, the only way that this could go is the Joker would make it a full house. Sorry, a 5 of a kind. So if we just think about this, if we have 3 Jokers and we have 1 other thing to make it a full house, so they share a different label. So if we have 3 Jokers, so if we say that these 3s are J's, we then would change them to a 2, which would make it 5 of a kind. And if we reverse it and say that the Jokers are the 2s, they would change to a 3, again making it 5 of a kind. So if J in counter T is equal to 5, else T is equal to the full house. Okay, so then we have if there are 3, so there is 3 and 3 cards, 3 individual cards, suits, if we like. Not suits, you know what I mean. 3 individual cards with the same label. 2 cards are each different from any other card in the hand for the other 2. So that makes it because that was the full house. So this is where it got confusing for me. So we had a full house, which is the one we just done. So now we're doing 3 of a kind, where 3 cards share a label. 2 remaining cards are different from any other cards. So we have 3 individual cards. One of the cards, there are 3 of them. Nice one. Okay, cool. So if J in counter, so we have 3 and a 3. So then what we're going to do here is upgrade it to a 4. So we're going to upgrade it to 4 of a kind. So if we had 3 Jokers, we would change it to the highest ranking card here, which would make it then 4 of a kind. If we had there's 9, let's say that was a Joker, we upgrade it to the T, which would make it a 4 of a kind. It would skip the full house. So then either way, we're going for a 4 of a kind. T is equal to 4 of a kind. And else T is equal to 3. Okay, now we get into the fun ones. So if we have 2 and 3 specific cards, 2 of one card, but there are 3 different cards in total. This is where things can change a little bit. So if J is in counter, and counter J is equal to 1, then we're going to be going for a full house. So with this example, if we have, so we've gone through the full house, we've gone through the 3 of a kind. So now I'm going for the 2 pair. So this is an example of a 2 pair. So if this 4 was a joker, it was then going to become a 3 because it ranks higher, or a 2, doesn't really matter. But it's the one that would give it the highest hand. So that would then become a full house, because we would then have 3 of one and 2 of something else. If the joker was 1. Now, in this same example, if the joker was the 3, then we're going to be changing 2 of the cards. And we're going to be changing the 2 of the cards to the 2, which would then make it a 4 of a kind. So, LF J in counter, and counter J is equal to 2, then this is going to become 4 of a kind, else that. Okay, so now we have, there are 2 and count of 2 of 1 card, but there are 4 different cards in total. So of this particular one, if the J is there, we're always going to be going for a 3 of a kind. So this is the 1 pair. So with this 1 pair, so this in particular, we got 2 aces, 2 A's here. So if these 2 A's were actually jokers, we'd be changing those to something else. So let's say a 2, and that would make it 3 of a kind. If it was one of these other ones, a 2, a 3, or a 4, it would become the ace. So therefore, it would still be 3 of a kind. So with this particular one, all we care about is, again, is there a joker? So if J in counter, type is going to be equal to 3 of a kind, else is going to be equal to 1, and then finally with this one, because we're just going to have 5 of the same thing, there is only 1 of everything. So if there's a joker, it's going to become a any card, doesn't really matter. So it's going to become a 1 pair. So this one we say if J in counter T is equal to 1, else T is equal to H. And then from there, we're still doing the same thing with the scores. The sorting is still the same, and we're still getting the total in the same way. So let's see if this works for this one. So let's do part 2, part 2. This one failed. I think I just need to change what we're solving for, the value. So this new one, we're aiming for 5905. 5905. Let's give it a run. We get a passing test, and this is the final output that we get for my input, and as we can see, it's the exact same as this one here. So there we go. There is 45 minutes of playing cards. Excellent. Right, have a good one. And that was day 7. Was it day 7? It was day 7. Day 7 of 2023's Advent of Code. See you for day 8. Thanks for watching.